Hello, I'm Carrie Meadows. Welcome to this webcast brought to you by Vision Systems Design. First, I'd like to thank Point Grey for sponsoring this event. This webcast is entitled Practical Guide to USB 3.0 for Machine Vision Applications and presented by Mike Gibbons, Director of Sales and Marketing for Point Grey. This presentation is live and interactive. You can ask questions by clicking on the Ask a Question button in the presentation window. If you are running pop-up blocking software, such as the Google Toolbar, please disable it to view this webcast. Also, please close down all other applications for better performance. This presentation is available on demand. A reminder email message will be sent to all registrants with a link to the archive. It will also be accessible from our homepage at www.vision-systems.com. In addition to supporting audiences on the Internet using Adobe Flash and Microsoft Windows Media, we now offer webcast viewing via Apple tablets and phones running iOS 4.2 Plus. You will now have seamless access to both live and on-demand web presentations from your iPad and iPhone. Now it's my pleasure to introduce Mike Gibbons.
Thanks, Carrie, and thank you everyone for joining us this morning. My name is Mike Gibbons. I'm Director of Sales and Marketing with Point Grey. So what we're going to take you through today is kind of the what, why, and how of USB 3. So we'll talk a little bit about the technology of USB 3, why it's of interest for machine vision applications, and then finally some of the actual practical considerations when it comes to implementing USB 3 into a vision system. So first off, a little bit about Point Grey. So we are a leading designer and manufacturer of USB, GigE, and FireWire cameras. We were founded in 1997, so this year actually marks our 15-year anniversary of being in business. We've got about 140 employees worldwide. We have quite a bit of experience with USB 3. We demonstrated the first USB 3 camera in September 2009. We've also developed quite a bit of proprietary USB 3.0 technology, including our own FPGA link layer IP, which we've implemented in an FPGA, as well as our own low-level driver. In 2011, October 2011 last year, we started series production of our ultra-small Flee-3 USB 3 cameras, which you can see pictured there. So basically, over the course of the last 3 years, we've done a lot of work on USB 3 and a lot of testing and development. So have some pretty good experience with that. Throughout the presentation, you're going to see some of these little tested check marks. So these are basically to indicate specific items that Point Grey has tested and verified over the course of the last few years. You'll also see tips located throughout. Okay, so let's get into the what. So this is just kind of what I'm going to do is spend a little bit of time on USB 3 technology and what's just a bit of the background on USB 3. So super speed USB is also known as USB 3.0 or USB 3 is the next generation of the plug-and-play universal serial bus serial communication spec. So that standard was originally developed by Intel, Microsoft, Compaq, and others. It's originally developed for keyboards and mice, and then those companies went on to found the USB Implementers Forum. Excuse me. In 1996, the USB 1.0 spec was released. That ran at 1.5 megabits or 12 megabits per second. So while those data rates were useful for keyboards and mice and that kind of thing, not so useful for video streaming applications or for vision applications. It wasn't until 2001 when USB 2 was introduced that it really became useful for video streaming. 480 megabits per second was sufficient for a lot of the vision applications around during that time. And so that basically led to the birth of the first USB 2 digital video cameras. Of course, like any interface, USB 2 has its strengths and limitations when applied to machine and computer vision. provides sufficient bandwidth for many applications, has built-in support on virtually every computer, and is typically very low cost. That said, USB 2 bandwidth may not be enough for many of the new high data rate image sensors, provides limited power, and is not as efficient as in its signaling as other interfaces. So a little bit about bandwidth. So probably one of the biggest advantages of USB 3 is the bandwidth, as well as the actual architecture underlying USB 3. So the maximum streaming bandwidth via bulk transfers is around 440 megabytes per second. The maximum via isochronous is 384 megabytes per second. So just to put that into context, that's about 10 times the bandwidth available with USB 2, 5 times that of FireWire-B, and about 4 times that of gigabit Ethernet. So the two main image streaming transfer mechanisms are bulk and isochronous. So what bulk does is guarantee delivery but not bandwidth. It also has error detection and retransmission mechanisms that ensure data is transmitted and received without error. And I think that's critical for any sort of machine vision application. Whereas isochronous guarantees bandwidth but doesn't actually guarantee that the data will reach the host system. It's also a host-directed protocol. This hasn't changed from USB 2. What that means is basically every transaction either goes to or comes from the master, which is typically the host computer. The host initiates all the data transfers, handles all the arbitration functions, and basically controls the whole data flow. The communication method has changed. So under USB 2, it was only half duplex, which means that data can only flow in a single direction at a time, which is obviously not very efficient. With USB 3, it's now changed to dual simplex signaling, which means that data can flow in two directions or both directions simultaneously, and again, much more efficient. USB 2 uses polling as the primary signaling method, which means that a USB 2 enabled camera would have to be constantly polled by the host software to check for activity. You know, it's basically asking the camera, are you ready to send data yet? Are you ready to send data yet? Obviously, again, very inefficient, and also causes a lot of processor usage on the host PC. With USB 3, we've changed to asynchronous notifications. So the camera will asynchronously notify the host that it has data available to send. And there you can see one of the things that we've tested in terms of throughput. You know, this is a basic desktop test where we ran 340 megabytes per second from 2 cameras into a single inexpensive interface card. A bit about backward compatibility. So USB 3, the actual connector and cable contains 5 new wires. So I've circled the 5 wires on the micro B connector there just to show the extra wires. It's backward compatible with USB 2, and I'll talk a little bit about that later. USB 3 standard A receptacles are backward compatible with USB 2, but add new pins. There's new standard B and micro AB receptacles, and then USB 3 introduces new micro B and micro A plugs and receptacles. So in terms of the vision, most USB 3 cameras you're going to see out there use the micro B receptacles. So again, that's the smaller connector that's shown in the picture there. And the main reason for that, obviously, is the size is quite desirable. And then most computer, hub, and interface card ports are going to be a standard A connector. All right, a little bit about power management. USB 3 provides more efficient power management. Probably the biggest thing, though, is it increases the power delivery over USB 2. So under USB 2, the amount of current a device could draw was about 500 milliamps at 5 volts, which results in about 2.5 watts of power. In super speed mode, under USB 3, you can now draw 900 milliamps. So it goes up to 4.5 watts at 5 volts, which is plenty of power to power any of today's cameras, and in some cases even a couple of cameras if they're running at less than 2 watts. What's interesting too is that there's a battery charging spec which actually allows up to 7.5 watts. This is actually already available on some host controller chips, such as the Fresco FL1100. A couple other things. I mean, there's just generally better performance management or power management in the sense of entering and exiting low power states. The other big piece is because of the architecture and the fact that it eliminates polling from USB 2. It's not consuming power, system power, to actually do that polling. So. Okay, so what I've got here is just a kind of a very high-level overview of the main digital interfaces and a quick comparison of those interfaces. So obviously, if one interface can cover all the requirements of a system, ranging from size, bandwidth, price, all that kind of stuff, it would be a clear winner. But in reality, you know, your requirements are going to be too diverse to be met by just one interface. When you look at USB 3, it kind of sits at the intersection of power, bandwidth, ease of use, and all that kind of thing. In terms of bandwidth, if we look at this, Camera Link is still the bandwidth king at about 680 megabytes per second. Although that said, you know, some customers may choose to sacrifice bandwidth in order to have the ease of use of USB 3. Like FireWire, USB 3 provides power and data over a single cable. USB 3 is almost 10 times as fast as FireWire and GigE, but that said, FireWire does provide significantly more power, about 45 watts of power. And then GigE, of course, is the cable length winner at 100 meters of inexpensive cable. And obviously the note here is that a lot of the information presented here is a bit subjective, and it also depends on the exact system configuration it's used in. So for example, GigE does provide power and data over a single cable using PoE and that kind of thing. So a little bit about USB 3 Vision. Some of you may have heard of USB 3 Vision. And just to give you a bit of quick background, so back in September of 2011, most of the major camera, cable, and software companies in the vision industry kicked the standard off, and basically USB 3 Vision was born from that. USB 3 Vision is an interoperability standard for devices based on the USB 3.0 electrical specification, and just in the same way that IDC and GigE Vision are standards for FireWire and Gigabit Ethernet devices. It allows for easy interfacing between the USB 3 Vision device and a computer using standard USB 3.0 hardware. It's managed by the AIA Trade Association, who also manages GigE Vision and Camera Link. It'll define standards for data transport, mechanical specifications for the cable, that kind of thing. That said, USB 3 Vision will specify, USB 3 Vision will not specify how to handle incoming USB 3.0 data packets. That's the job of the actual USB 3.0 spec. That said, USB 3 Vision will specify that USB 3.0 bulk transfers be used for data streaming. There's a bit of a fine difference there between the USB 3 Vision spec and then the actual super speed USB specification. First draft of the USB 3 Vision standard is being completed and is currently under review. And then a quick thing on logos. So we've got, you may have seen a few different logos out there. So the first there is the super speed certified USB logo. This is actually a logo that devices that have gone through the USB 3.0 compliance process would be able to use on their devices or in their marketing materials, that kind of thing. You won't typically see this logo used in our industry. Not many devices are super speed USB certified. USB 3 Vision, on the other hand, you will see this quite a bit, and you'll likely see lots of camera software cabling vendors using this logo to show that their devices or their software are USB 3 Vision compliant. The third one there, that's Point Gray's USB 3.0 logo, which we designed when we were first coming out with USB 3 products. And then the final one there is what you would see on computer ports, cables, that kind of thing, which is a very small super speed logo. So that's it for the technical primer. So let's talk a little bit about why you would want to use USB 3 in machine vision. Ultimately, I think everyone wants more pixels. They want faster frame rates, better reliability, lower cost, all that kind of good stuff. So, so what I'm going to try to talk about here in this section is just some of the how USB 3 addresses the need for higher bandwidth, reliability, cost, all that good stuff. So this is kind of a useful graph. It kind of shows the comparative throughput of the major different interfaces. So you can kind of see USB 3 there in the purple, running at 400 megabytes per second. Camera Link again is the interface leader with a full configuration. What this is, so just to give you a couple of points about why the bandwidth is actually important. So one is that you can run faster and or higher resolution sensors. And I think we're all aware of some of the image sensors that are out there today, and they're getting faster, and they're just basically have more pixels. You can also get higher bit depth from an existing sensor. So you can, instead of outputting just 8-bit data, you can output 10-bit, 12-bit, 16, 24-bit data, and have bandwidth to accommodate that. And then as well, the higher bandwidth allows you to simply get more cameras on the same bus. And this will have an impact on your cost in the sense of not having to buy as many interface cards. You can have a single interface card that supports multiple cameras. USB 3.0 also provides better reliability, and there's a few reasons for that. So most of the cameras and cables you're going to see today use screw lock connectors, and this basically ensures a secure connection, right? So these are the little thumb screws that allows you to screw the cable into the camera, cable into the card, and that obviously ensures reliability. There's also increased power delivery, which reduces power-related problems. So, if you've got a camera that's drawing a little bit more power than it should be, then that's going to, basically you have enough power that it's going to be able to accommodate that. The actual host silicon, the XHCI host controllers, support a packet resend mechanism, and this is very, very helpful to address issues with data corruption. So if you have bit errors, it does have a mechanism to detect that and then resend those packets. And again, it's critical for vision applications to have every single bit of data possible coming from the camera. The actual super speed USB compliance process itself ensures proper operation of peripherals. So cables, hubs, those kinds of things, they all go through this compliance process to make sure that they adhere to the USB 3.0 specification. One small tip. On-camera data buffers help minimize the chance of dropped or corrupt data. And I'll talk a little bit about data. They're also known as frame buffers a little bit later. So again, something to look at when you're looking for cameras. All right, so we're talking about lower system costs. So here what I've done is just a very, very brief example of how USB 3 compares to the other interfaces in terms of system cost. Wherever possible, I've tried to get prices from a single source. So a lot of the prices are actually from our own Point Grey online store. I've also got some pricing from Edmund Optics and StarTech. What you can see here is that USB 3 is a clear winner in terms of cost for both single camera as well as multi-camera solutions. Particularly with a four camera solution, you can buy a 4-port USB 3 interface card for $70, and then those you can connect 4 cameras directly into it. I haven't factored the cost of the camera into this, assuming you can get a camera that's the same cost for all the interfaces. The other thing I've tried to do in this table is basically using pricing for products that are industrial grade, so metal enclosures, screw locking connectors, all those kinds of things, as opposed to just pure consumer products. And then camera link in this example assumes a base configuration. So as you can see here, excluding the camera, you can develop a 4-camera solution for well less than a couple $100. Lower processor usage. So I think most people want as many cycles on their system to process process the images for their vision application as possible. So they don't want to have any time spent doing anything else. So the beauty with USB 3 is that it uses asynchronous signaling, which does eliminate the polling mechanism of USB 2. In our tests, we found that USB 3 definitely requires less CPU time than USB 2, and USB 3 is generally similar to FireWire in terms of its processor usage. USB 3 also supports DMA transfers, so direct memory access allows data to be read from and written to main memory without going through the CPU. And then, of course, the increased bandwidth allows more data to be transmitted. So, for example, the camera can send full color processed images because it has that bandwidth to do so. This removes the requirement for the host system to actually perform this processing. So all these things contribute to basically less processor time spent handling the camera and its data, and more processor time spent actually doing the vision application. Okay, so the other thing too is USB 3 is widely available. Because it's a low-cost consumer-driven technology like FireWire and GigE, you'll find it everywhere. USB is the most popular interface of all time, and is basically forecasted to be in every PC by 2015. At this point, virtually all major computer system manufacturers provide systems with USB 3 on the motherboard. There's also add-in cards widely available for those systems that don't. AMD and Intel both have certified USB 3.0 chipsets. So these are CPUs that basically have USB 3 built into it. These are shipping. They're in systems today. It's also important to consider future bandwidth requirements, which are often driven by the image sensor technology. So many of the new image sensors that are on the market today require much more than 100 megabytes per second data rates, which again take us into basically USB 3 and camera link territory. So there's new Sony CCDs. There's a wide range of new CMOS imagers coming out. And as you can see here, there's a number that get well over 200 megabytes per second of data rates. And again, your choices become limited at that point to either USB 3 or camera link. Okay, USB 3.0 interoperability. So interoperability between the components in the imaging pipeline is a very important consideration. You probably don't want to feel tied to any one particular vendor, whether it's for your cameras, cables, or third-party machine vision software. So again, this is where USB 3 Vision fits in. USB 3 Vision will draw many of its specs from GigE Vision, so it has a lot of similarities to GigE Vision. It also relies on GennyCam. Cameras, for example, will have an XML file that defines the supported features. Currently, the USB 3 Vision spec is requiring the transport mechanism to be bulk. Future versions may add isochronous as an option. One thing to note is that backward compatibility with USB 2 is not required. So you may, if that's important to you, you should check with your camera vendor to make sure that they do support USB 2. The standard is designed to support zero copy, unlike GigE, which copies every packet. USB 3 Vision also defines a standard for the actual screw lock connectors on the cables. USB 3 is great for multiple cameras, so theoretically you can network up to 255 units on a single USB bus. One thing to keep in mind when it comes to multiple cameras is system processing. So obviously the more cameras you have in a system and the amount of more data that you're sending through, you have to be able to process that. One thing to keep in mind again is a camera frame buffer is critical to ensure data is not corrupted. As an example of some of the testing that we've done long-term tests with 24 cameras on a single PC. In these tests, we used 3 cards, 6 4-port hubs, and basically networked them all together in a single system. Okay, so that takes us through the what and the why. So let's look a little bit at the how and some of the practical aspects of implementing USB 3. System requirements. So obviously there's lots of different components that are part of a USB 3 enabled vision system. One thing to keep in mind is that USB 3 technology is still relatively new, so it's very important to have the ability to upgrade or downgrade firmware and software of the various system components. So most hubs, cameras, and interface cards are going to have firmware that you can upgrade on the actual devices themselves. There's also software drivers on the host system that you should be aware of. And so being able to update those various components is a pretty key piece to making sure there's no issues. Okay, let's look at the host system for a second. So one thing I think in many vision applications, the end user actually provides their own PC. So the integrator or whoever does not actually have control of the end PC. So in these cases, backward compatibility with USB 2 is critical. You're developing a system, you're deploying it, and someone may have an old laptop that only has USB 2, but they still want to run that system. So here are some of the things we've tested. So we've basically tested a USB 3 camera plugged into a USB 2 port. That'll work, no problems. The only issue is it works at USB 2 speeds. You also have to make sure that there's enough power provided. So again, 2.5 watts is what USB 2 provides. So if you have a camera that's going to draw more than that, that could be an issue. USB 2 camera plugged into a USB 3 port will also work. Again, it'll only run at USB 2 speeds. And then if you want to network both USB 3 and USB 2 cameras into a USB 3 port, that's again not a problem, and they'll both operate simultaneously at their respective speeds. One thing to keep in mind is that practical bandwidth is a function of the USB 3 chipset and the motherboard chipset. So some motherboard and USB 3 combinations actually result in slower data throughput. And we have an application note on our website that describes some of these problem scenarios. In terms of systems that Point Grey has tested, we've tested a whole bunch of different combinations of motherboard, CPU, and USB 3 chipset configurations. I've listed a bunch here. I'm not going to go through them obviously at this point, but a number of them that we've tested are listed here. Again, we've also got an app note that describes a lot of the systems that we've tested. One encouraging thing is that there's lots and lots of laptop options available now that provide onboard USB 3 connectivity. Again, that's one of the big draws, I think, of USB 2 is that easy support. And now with USB 3, you've got a pretty wide range of laptop solutions available, even ones that are well under $1,000. Okay, operating system support. Windows 7 does not provide native USB 3 support. The good news is that Windows 8 will, and there's lots of, if you have access to Windows 8 betas, give it a try, and you'll find that there is indeed good USB 3 support there. To address the lack of support under Windows 7, there's a couple of options. So Point Grey, we've actually developed our own XHCI driver. As well, all the host controller manufacturers out there provide their own XHCI drivers. So there's really no issue at all running USB 3 under Windows 7. There's lots of driver support out there. Apple, they have not announced plans to provide native USB 3 support. That said, the latest MacBook Pro systems that are available now provide USB 3 support. They actually have 2 USB 3 ports on them, and that's as a result of using the new Intel Ivy Bridge chipset. Linux, they actually started supporting USB 3 back in 2009. At the time, it wasn't appropriate for video streaming, but the very latest kernel versions do appear to have video streaming capability. We've done some testing of the latest kernel, and it works quite well. It does require a little bit of effort to actually compile the kernel, but it does work. Okay, software. So the USB 3 Vision standard will be key to ensuring USB 3 Vision compliant cameras run seamlessly with compliant software from all the major software companies. As well, most camera vendors like Point Grey also provide their own SDK for interfacing with cameras. So one thing to make sure of is ask your vendor whether their SDK allows you to connect multiple different interface cameras from them and have it run. So with our SDK, for example, you can run Gigi, USB, FireWire cameras all using the same user application. In terms of Mac, Point Grey, we've actually done some testing with our USB 3 cameras. We can run our USB 3 cameras, unfortunately just at USB 2 speeds, but we can run them on Mac OS using the cross-platform Linux libUSB and libDC libraries. So if you're interested in those, have a Google those and you can get more information. Okay, hubs. So hubs are obviously critical for any sort of multiple camera application if you have large networks of cameras. There's hub chipsets available from a number of different companies. All of them claim to be USB 3.0 compliant. That said, none are officially certified since the actual USB 3 compliance tests for hubs are still not defined. That said, we've tested a whole bunch of different hubs. We've listed some of them here. They range in price from $50 to a $200 board level hub from TI. One thing that we've found actually in some of our testing is that hubs can limit data rates compared to direct connect into a host. So the test that I mentioned earlier on using 2 cameras where we were streaming 340 megabytes per second into a card, in that test we saw a 20% drop down to 272 megabytes as a result of this. And this is a result of the host controller's fairness policy. It basically results in a large number of double acts. So at this point we understand what's happening, and we're investigating ways to minimize that performance loss. But again, something to be aware of. Cables. So the maximum cable length is actually not explicitly specified in the USB 3.0 standard. It basically specifies the electrical spec for a cable. So what are the minimum voltage requirements and all that kind of thing. At this point, most camera vendors and most cable vendors are providing 3 to 5 meter cables with the screw locking micro B connector. A lot of the cable vendors are also working on 10 meter solutions. There's also work in progress on active repeaters and optical repeaters from companies like Elysium Tech, CEI, and Nunex. So these will get you even further distances. There's a bunch of other interesting hardware out there that supports USB 3. So AdLink, for example, has a fanless embedded PC that has 2 USB 3.0 ports. IOI Technology, they're a Taiwanese peripheral manufacturer. They've also got an interesting 4-port USB 3.0 card. So again, this gets you 4 ports without needing a hub. And cameras. So cameras are now readily available from many of the key vendors. I've put up on the screen there some pictures of some of the cameras that are out there. USB 3 connectors are relatively small, and the low power technology enables small camera designs. So you're going to see a lot of these cameras are ice cube sized or potentially even smaller. Most are CMOS based, and part of the reason for that is it's, CMOS, a lot of the CMOS image sensors have higher data rates, so they can actually take advantage of USB 3 bandwidth. They're lower power, and they're easy to implement. Many USB 3 cameras use the Cypress Easy USB FX3 chip to enable the USB 3 connectivity. This is basically the chip is a general purpose USB 3 device controller. Point Grey does not use it. We've created our own USB 3 link layer, which we load into an FPGA, but we have worked extensively with the FX3. Common implementation consists of a CMOS sensor connected to the FX3 with a small FPGA connected. According to Cypress, the FX3 can sustain performance of up to about 320 megabytes per second. One tip: look for cameras with large data buffer. So again, I've mentioned this, so I'll talk a bit about it now. This is a dedicated memory on a camera that can be used to temporarily store image data. This allows the camera to handle temporary slowdowns in the USB 3 interface without dropping any data. It's really most useful for bulk transfers. Isochronous transfers have guaranteed bandwidth and wouldn't be impacted by issues with the PC not keeping up. One really important thing to note, and this applies to a lot of vision applications that are triggered, is that with a frame buffer, a single triggered image will always arrive using this mechanism. And again, this is crucial for any triggered machine vision application. The other advantage of a frame buffer is that if the overall USB 3.0 throughput drops below the camera's frame rate for an extended period of time, the camera can actually send an entire uncorrupted frame out slower and drop entire frames cleanly, rather than drop partial frames and cause image corruption. So again, the whole purpose here is to avoid any sort of data errors in the actual image data. So this brings us to the future. So what's coming down the road? So I think in terms of availability, USB 3 enabled device shipments are forecast to surpass 1 billion in 2014. And again, you probably saw earlier the graph that basically by 2015, 100% of computers are expected to support USB 3.0. Power, there is discussion among USB IF member companies about providing even more power, even up to 100 watts over USB 3. So this, again, is great for large networks of cameras. Standardization, I think the goal at this point is for the USB 3 Vision standard to be ratified by the end of 2012. And then finally, Vision components. So, if any of you get a chance to attend the Vision show in Stuttgart, or if you manage to get to the Vision show in Boston that happened just recently, you probably see more and more USB 3 enabled cameras, cables, and software from most of the key vendors. So there's just going to be a lot more choice out there in terms of components for your vision system. So to sort of conclude all of this, USB 3 is fast, 400 megabytes per second. You get more cameras in the bus. You can use faster, higher resolution sensors. USB 3 is easy. It's plug and play, one cable for data and power, backward compatible with USB 2. And it's accessible. It's basically everywhere. It's a ubiquitous technology. And best of all, USB 3 is actually available today in shipping in cameras, cables, and software. And I think that brings us to the end of my presentation. So I'm ready for your questions.
Sure.
I guess back over to you, Carrie.
Thank you, Mike. We do have a few questions from the audience. The first question is, are there any active cables or cable extenders available to extend the camera-computer distance further than 3 meters?
Okay, that's a good question. So yeah, I mentioned earlier in the presentation that yes, these things are in active development. So optical repeaters and active repeaters are being developed by companies like Nunex. There's actually also a company called Icron Technologies that's developing optical repeaters. Most of the standard cables that you'll see today are around 3 meters, but they are going up in length. 10 meter cables are available now from a lot of the cable vendors. So.
Okay, The second question starts with, I do not understand where the presenter gets his 7.5 watts USB battery charging specification number. If this number is true, will not this limit the use of USB to a limited number of cameras?
So the 7.5 watts is actually from the USB battery charging spec. It's version 1.2 of the spec, and I can send a link offline if that's useful. But basically, again, the USB-IF spec allows for a power draw of up to 900 milliamps. With the battery charging spec, you can draw up to 1.5 amps of power at 5 volts. So that basically is 7.5 watts. In terms of limiting number of cameras, in practical applications of multiple cameras, whether they're FireWire, GIGI, or USB, a powered hub is still typically used. Most of the USB 3 cameras you'll find on the market today run well less than 2.5 watts, which, if you do the math, would allow 3 cameras to be bus powered.
All right. Another question is, if multiple cameras are used in a USB system, what standard in USB 3 vision will determine how the host CPU divides the system bandwidth?
Okay, so that's a good question. So USB 3 vision, again, that's basically an interoperability standard, just in the same way that GIGI vision is a standard for gigabit Ethernet devices. So USB 3 vision doesn't actually specify how the host system will handle incoming USB 3 data packets. That said, it does specify what transfer mechanism should be used for data streaming. So bulk is that transfer mechanism. So in all cases, the USB 3 XHCI controller manages those data transfers, not the host CPU. So again, it's the USB 3 vision spec specifies that interoperability, whereas the actual super speed USB spec defines the actual transport mechanisms and the actual underlying interface.
Okay. Next question. Why do most USB 3 cameras available today use CMOS image sensors? How about CCD?
So that's kind of interesting. Most of the cameras you're going to find are CMOS based right now. There's a few reasons for that. One is that a lot of the CMOS imagers that are available today need that USB 3 bandwidth, right? You've got 1.3 megapixel, 150 frame per second imagers, and if you do the math, you're going to need far more than 100 megabytes per second. So they fit well with USB 3. They're also typically lower power, which means you can build very compact cameras without causing power and heat issues. And in general, CMOS is just easier to integrate from an engineering perspective. To take advantage of the higher image quality available with CCD requires more complex electronics.
Okay. Why have your own SDK when the USB 3 vision standard is available? Lots of camera vendors provide their own SDK, and one of the main reasons for that is generally they're free. So in our case, our fly capture SDK is free, which allows you to develop a custom application that interfaces with our cameras at no cost. A lot of the third-party software packages that are out there that will be USB 3 vision compliant, you do have to pay for. And of course, there's advantages with that as well, as a lot of those software packages have the vision processing capabilities that our fly capture SDK does not. Okay. Someone else is commenting on slide 31. There were pictures of a few different cameras. Okay. One of them looked like it had a standard USB socket rather than the 3.0 socket. Is that an alternate connector for USB 3? No, that I believe is a standard B connector.
So that's like it's kind of the squarish connector that, and I'm assuming they're talking about the R-tray camera there with the one on the bottom there. That's as far as I know, that's a standard B connector, and I believe R-tray came out with that camera quite a little while ago, and I'm not sure why they selected that camera, but again, you're going to find that most of the cameras that are available on the market today use the micro B. Main reason being is that it is quite a bit smaller, allows you to have a much lower profile design.
Excellent. One last question from the audience, and then we'll have to wrap it up.
Sure.
Will Thunderbolt be a competitor to USB 3?
That's an interesting one that does come up from time to time. So I mean, Thunderbolt, it's a high-speed interface. It's basically championed by Apple. It does offer quite a bit higher bandwidth. It's about 10 gigabits per second. It's not clear if there's a feature for Thunderbolt as a digital interface technology for industrial cameras. It's really not clear what the benefit would be of multiplexing PCIe with DisplayPort and how that benefits, the vision industry. I think what's clear is that USB 3 is far more ubiquitous in the consumer space. Again, you're seeing it on pretty much every computer now, and again, that's key to driving developments in the vision industry. If you do a Google search for Thunderbolt versus USB 3, you might come across an article by Dan Harmon from TI. He wrote a really good article that kind of compares and contrasts the two interfaces. So.
Great. That's excellent information. Thank you, Mike.
Yeah.
Unfortunately, that's all the time we have for today.
Great.
But if there are questions that we didn't address during this session, they will be answered offline after the presentation.
Excellent.
And
well, thank you very much, everyone, for your time.
Thank you. On behalf of Vision Systems Design, I'd again like to thank today's speaker, Mike Gibbons, and our sponsor, Point Grey, for this webcast. The presentation will be archived within 24 hours, and it can be accessed from our homepage at www.vision-systems.com. Thanks for attending, and please look forward to future webcasts from Vision Systems Design.